We have a triangle ABC that we have to reflect across the y-axis. There's a couple of different methods for achieving this. One method is to simply use the coordinate plane itself to do the reflection. Before reflecting this object across the y-axis, let's make sure we first know where the y-axis is. On a coordinate plane, the y-axis is the line which goes up and down. We must make sure that our object is reflected across that line. Now, let's take a look at point C. Notice that point C is exactly 4 units to the left of the y-axis. So just take point C and move it 4 units to the right of the y-axis. That's the new location of point C. Point B is located 4 units to the left of the y-axis as well. So make sure to do the opposite and move it 4 units to the right of the y-axis. Take a look at point A. Point A is located 7 units to the left of the y-axis. So let's simply move it 7 units to the right of the y-axis. And we have found the 3 new locations of point A, B, and C to reflect it across the y-axis. Now, let's write down the ordered pairs of the new points. Point A is located at +7, -6. Point B is located at +4, -6. And point C is located at +4, -2. Now let's compare our new points to the old points. As you take a look, the absolute value of each of the coordinates stayed exactly the same, meaning that A had an absolute value of 7 and 6, and when we changed it, the number still stayed 7, 6, but there was one thing that did change. Take a look at each of the x values. All of the x values were negative, and after we reflected the object, all of the x values became positive. That brings us to a rule. Whenever we reflect anything across the y-axis, all of the y values will remain the same, the number as well as the sign. But for the x values, the sign will become opposite of what it was before. So for point A, it was -7 and it turned into +7. B and C were both -4 and we changed those both into +4. Now let's use the same rule to reflect triangle ABC across the x-axis. The same rule will apply, except for when reflecting something across the x-axis, it's the x values which will remain the same, and it is the y values that we will have to change the sign to the opposite of what it was. So let's just rewrite all the x values exactly the same, -7, -4, and -4. Now let's take all of the y values. Because each of the y values were negative, simply turn them positive. So instead of -6, -6, and -2, we now have 6, 6, and 2. Now we have the location of the 3 new points when reflecting our original triangle across the x-axis. Now let's plot each of the ordered pairs. The new point A is going to be located at -7, +6. The new B location is at -4, +6. And point C is located at -4, +2. And when you connect all of the dots, we have our new right triangle, ABC, which was reflected across the x-axis.
We are going to take a quadrilateral and rotate it 90 degrees clockwise around the origin. Now the origin is simply where the x and the y-axis intersect, which is located at the coordinates 0, 0. Now some things that we should review before we actually figure out where our quadrilateral is going to end up are the features of each of the quadrants. Quadrant number 1, all x and y values will always be positive. In quadrant number 2, all x values are negative and all y values are positive. In quadrant number 3, both the x and the y values will be negative, and in quadrant number 4, the x values are always positive and the y values are negative. Now, Before we can actually rotate this figure, we first must find the ordered pairs of each of the vertices of our quadrilateral. Point A is located at positive 2, positive 5. Point B is located at positive 6, positive 4. C is located at positive 6 and positive 2. And D is located at positive 2, positive 2. Now we know we have to rotate our figure 90 degrees clockwise about the origin. A 90-degree rotation on one of these grids always just means moving it directly to the next quadrant over. If it's a clockwise rotation, move it to the next quadrant going right. If it's counterclockwise, move it to the quadrant directly to the left. And there's an easy way to do this to precisely figure out where your figure is going to be transformed to. Simply take each of the ordered pairs that you have written and switch the order of them. Because A was located at 2, 5, switch it to 5, 2. Because B was at 6, 4, change it to 4, 6. C was at 6, 2, change that to 2, 6. And D was 2 and 2, and if you switch it, that's the same thing, which is 2 and 2. Now, we must go back to what the features of each quadrant are. We know that in quadrant 4, all x's must be positive. So I'm going to keep all of my x values positive. But in this quadrant, all y values are negative, so we simply take a negative and write one in front of each of the y values. These new coordinates tell us exactly where we should plot each of our points. After we plot each of our points, just connect the dots, and we have transformed our quadrilateral 90 degrees clockwise around the origin.
In this lesson, we are going to translate a polygon, positive 3 in the x direction and negative 4 in the y direction. Whenever moving an object in the x direction, it simply means moving it to the left, which would be a negative movement, or to the right, which would be a positive movement. Because it is positive 3 in this case, we are going to be moving our polygon to the right. And in the y direction, this always means to move it either up or down. A negative number means we have to move our object down. A positive number means we have to move it up in the y direction. In this case, we are going to move our polygon 3 units to the right and 4 units down. To accomplish this, there are a couple ways of doing this. You could take each point and simply count 3 over to the right and 4 over down and then label your new point. Or you can just write the coordinates of your original points, and then for the x value, you can just add 3 to each of the x values to see where your point is going to end up. And for all of the y values, you can simply subtract 4 from each of them to figure out where your y coordinates are going to be. Now we are going to double check our work like a good math student does. When you work with translations, all you have to do is add the movement of the x direction to your original x location, and the sum should equal what the new x location is. For example, for point A, the x value was negative 8. If we were to add positive 3 to negative 8, it does make negative 5, and that's exactly where our new A point is located. For point B, we started at negative 4, and negative 4 plus 3 does make negative 1. For point C, we were at negative 5, and moving over 3 to the right, we would indeed end up at negative 2 on our x-axis. And for point D, we started at negative 7, and negative 7 plus 3 does make negative 4. Now to check the y values. A was originally located at positive 1 on the y-axis. If we subtract 4 from positive 1, we would indeed end up on negative 3. For the B point, we were at positive 2. Positive 2 minus 4 does make negative 2. For point C, we were at positive 4, and of course, 4 take away 4 makes 0. And the same thing for point D. We were at positive 4, and 4 minus 4 is also 0. So anytime you are performing a translation, you can simply take the movement in the x direction and add that number to all of the original x values to get your new x values. For any movement in the y direction, you simply add that number to all of the original y values to get your new y values.
and that will give you the new coordinates of your translated object.